First, we will review how to divide polynomials. So if we would like to divide 2x cubed plus x squared minus 8x plus 5 by x plus 3, we should first recognize that we can use synthetic division. It is much simpler and faster to divide this way. So if we're going to use synthetic division, remember we want to put the opposite of 3 on the outside of the division box. So we want to use a -3 when doing synthetic division. And then we want to put the coefficients on the top. So we'll put a 2, a 1, a -8, and a 5. So now remember with synthetic division, we take the first number and drop it down, and then we take that 2 and multiply it with the -3, and we get a -6. And we write that -6 right underneath the 1. And then we add 1 and -6 together to get -5. Again, we multiply and get a +15. Add that together to get a 7 and a -21. And that will become a -16. And so this question is just asking us to find the remainder. So our remainder is -16, but we need to put that over what we were originally dividing by. So -16 over x plus 3. We're going to do the same thing with number 2. It's basically asking the same question. So since we are dividing by x minus 1, we want to put a +1 on the outside of the synthetic box and all of the coefficients on the inside. -1 and -1. So if we drop down the 1, 1 times 1 is 1, 4 plus 1 is 5, 1 times 5 is 5, 4, 4, and 3. So our remainder for this problem would be 3 over x minus 1. For number 3, we want to just FOIL it like normal, but notice that we have some x's in the denominator, so we just need to be a little careful when we're simplifying the algebra. So 2 over x squared times 3, remember this is really a 3 over 1, so that will become 6 over x squared. And then 2 over x squared plus or times 4 over x would be 8 over x cubed. And then -4 times 3, of course, is a -12. And then -4 times 4 over x would be -16 over x. So now we want to be able to combine all of these terms by giving each term a common denominator. So if we notice, x cubed is the biggest degree in the denominator, 8 over x cubed. So we want all of the denominators to become x cubes. So to do that, we can take our first term and multiply him by x over x. We don't need to do anything to the second term because he's already an x cubed. For the third term, we can multiply by x cubed over x cubed. And then for the last term, we can multiply by x squared over x squared. So that will give us 6x over x cubed plus 8 over x cubed minus 12x cubed over x cubed minus 16x squared over x cubed. And then for our final answer, we can write the entire numerator over x cubed and just make sure that we write it in a decreasing degree. So we have -12x cubed minus 16x squared plus 6x plus 8 all over x cubed. Make that look like a 3. For number 4, we want to find the distance from the point 3, 4 to the point 1, 5. So remember for this, we have the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we are going to have 1 minus 3 squared plus 5 minus 4 squared, all underneath the square root. And that is going to give us a negative 2 squared, which is 4, and a 1 squared, which is 1. So we just get the square root of 5 as our final answer because we can't simplify that any further. To find the equation of a line containing the points 2, 0, and 5, 4, we need to know two things in order to write an equation of a line. The first thing we need to know is the slope. So let's use these 2 points to find the slope of the line. So remember, to find slope, we use m equals y2 minus y1 over x2 minus x1. So we have 4 minus 0 over 5 minus 2, which gives us a slope of 4/3. So now remember that if we know the slope of our line and a point that it goes through, in this case we know 2 points, but we only need 1, we can use point-slope form to write our equation of the line. Point-slope form is y minus y1 equals m times x minus x1. I'm going to use the point 2, 0 because that looks like it would be pretty easy to plug in. So for my y1, I'm going to plug in 0, so that will just give me y equals. For my slope, I'm going to plug in 4/3. And then for my x1, I'm going to plug in 2. So I have y equals 4/3 times x minus 2. And we can distribute the 4/3 to get 4/3 x minus 8/3. In number 6, we are asked how many points are on the intersection of y equals x squared plus x minus 12 and y equals 2x plus 1. So now we need to remember that the number of points of intersection is the same thing as the number of solutions. So if we can figure out the number of solutions for this system of equations, we will know our answer. So to do that, I'm going to begin solving this system. And if we have y equals x squared plus x minus 12 and y equals 2x plus 1, I can use substitution to plug this 2x plus 1 in for that y. So I have 2x plus 1 equals x squared plus x minus 12. And I am going to subtract the 2x and the 1, so I can set this equal to 0. So I have 0 equals x squared minus x minus 13. So the problem with this quadratic is that it is not factorable because 13 is our prime number and there's 1 and 13 wouldn't make a negative 1 in the middle. However, if you remember about quadratics, we can use the discriminant to determine how many solutions this quadratic equation would have. The discriminant is b squared minus 4ac. It's the part of the quadratic formula that is inside of the square root. So if we find the discriminant, we'll know how many solutions we have. So for b, I'm going to plug in a negative 1. For a, I'm going to plug in a 1. That's the coefficient in front of the x squared. And for c, I'm going to plug in negative 13. So I'm going to get 1 times negative 4 times, 1, and then negative 4 times negative 13 would be a positive 52. So I end up with 53 as my discriminant. Since 53 is a positive number, I know that I will have two solutions. If the discriminant ended up to be 0, we know that we would have one solution, and if the discriminant was a negative number, we would have no real solutions. So now that I know that I have two solutions, I know that there are 2 points of intersection. You can also type these two equations into your graphing calculator and notice that they intersect in 2 points.